Hello everyone and welcome to the second part of Module 1. In the first part we saw the double slit experiment and we were left quite surprised by it. In particular, we saw that when the source in a double slit experiment emitted a photon, this seemed to be behaving like a particle in the sense that it landed at a very well-defined point on the detector screen. However, when the source emitted a large number of photons, the detector screen revealed an interference pattern, which is typical of a wave. And what was even more surprising is that when we added an observer, just looking at whether the photon goes through the left or through the right slit, the interference pattern completely disappeared. And so in this second part, we will very informally write down the axioms of quantum mechanics. And recall that the axioms of a theory are the most basic rules that the theory assumes to be true. And in doing so, we will discuss two key concepts in quantum mechanics, and also very much in quantum computing. These are the concepts of interference and of a measurement. Now, I want to start by reviewing a little bit better the concept of interference, since you might not be entirely familiar with it. So interference is a concept that pertains to waves. In particular, it tells us what happens when two waves overlap at a certain point. Now, a wave can be described by a function that specifies the height of the wave at any point in space. So the graph in this widget shows a snapshot of a wave at a fixed moment in time. So we're fixing time, this is just a snapshot. And the function f of x here, this is just an example, gives the height of the wave at any point x in space, on the line in this case. Now the exact form of f of x is not important here, but the function f of x in this case has three parameters that we can adjust in this widget, and this will change the shape of the wave. For instance, changing a, which is known as the amplitude, changes how tall the wave is. So a is called the amplitude. Now changing lambda, which is called the wavelength, changes the distance between two peaks of the wave. And changing phi just translates the wave backwards and forwards, leaving the shape the same.